The work that I'll be presenting today is preliminary work, as you might see already in the subtitle, which has changed even a little bit according to what I submitted to Volker. I hope you don't mind about that. When does it pay off to learn a new skill, revealing the complementary benefits of cross-skilling? And I think this new word, I substituted economic with complementary. And I think, I hope that you will notice throughout the talk that this is really an essential word. And I felt that it needed to be put someplace. And I can't guarantee that this title won't change over the hopefully not too lengthy process of working on this paper and in this field. But I'm very happy to present these preliminary findings, and I'm, as you can imagine, very thankful for comments and suggestions that then will be diligently incorporated into the work that is growing out of this working paper and this presentation. I also added a subtitle which is called or Why We Are All Penguins, which might be a bit puzzling to people out there, even though I think now with a freezing cold winter here in Berlin, and I guess in many other places, and unfortunately the fate of social isolation due to the pandemic, we can kind of relate to penguins in a certain sense. Right now, but though this is not the reason why I suggested that we might be all penguins, you'll see soon enough what I actually mean with that. But let's move from penguins to a bit more serious matter actually, and that is one of the, if you may call it like that, mega trends of our times. It's automation, and as an economist, I think I know pretty much that, or I'm well aware that a lot of fellow economists, see this as an evergreen, in their literature. There's even kind of a fetish, I think, even that has developed throughout the years when economists talk about automation and sketch a future that might look something like that, human beings, human existence, or the human work being marginalized, pushed to a border, and the robots, or to make it more realistic, intelligent algorithms take over our work and do the jobs that we loved or maybe didn't love so much to do in the past. After this first, rush of fear of automation, economists and social science researchers developed a more nuanced paper about about how our work life might be affected by smart technologies and intelligent algorithms, and that is looks much more like this. It doesn't look the way that we'll be automated away entirely and be completely useless on the labor market. It's more that as technology advances and also social transformation processes advance, digital technologies enter our labor market, and they also enter our labor market in disciplines like, for example, farming and nursing that have previously been defined by more and more manual work. So what we see in general is a change of tasks, of task compositions of professions. So these incremental little pieces that build up our occupations, our professions, they change as digital technologies enter, and a specific type of tasks, non-routine cognitive tasks, as many economists have pointed out, for example, Acemoglu, an author, they become the new paradigm. They become more and more important. So it's non-routine, and most of them non-routine cognitive tasks, in contrast to routine manual tasks, for example. They are of increasing importance on the labor market. So there's a huge reshuffling going on. And one of the papers in the last decade that pointed this out, with I guess the lion's share of popular attention on it, was the work by Frey and Osborne, a study from 2017, where they kind of extrapolated what these computer-induced or algorithmic-induced automation might mean to the labor force, and which occupations would be most dramatically affected by the automation of certain tasks and the reshuffling of certain task profiles. And what we see is pretty interesting. It is not so much that the relatively simple manual tasks are the ones at highest risk of automation. It's much more, as we can see in this kind of probability plot of how likely an occupation will be affected by automation. It's much more what Richard Baldwin would call white-collar jobs, or a hollowing out of the middle spectrum of the labor market. So we see high automation risks due to task automation, or the changing task composition in sectors like sales, service, admin. So professional service and the professional admin sector is deemed to be most affected by this change. And furthermore, what we see on a macro level is a rather paradoxical situation, that as these task compositions, these technology-induced task composition changes happening, we see that old occupations kind of cease to exist. They become smaller and smaller. New occupations emerge where people are often required to quite skillfully master these new emerging technologies. But this change is happening so rapidly that a skill mismatch, a labor market mismatch occurs, with the rather paradoxical situation that there are people still left on the labor market that have that know the tasks of jobs that maybe no longer exist, and there are already new job opportunities that require tasks where you don't find adequately skilled labor on the labor market. So you have this paradoxical situation of an oversupply and an excessive demand on the labor market. And this can be, as we know from many economic studies, be very damaging to things like economic growth, firm growth as well, innovation, and also potentially causes rising inequalities in our society. So in light of this, rather threatening picture, there are some researchers that have been thinking about how to tackle this big problem. And the good news is, even though this is going to be a dramatic shift, and I think most economists would agree on this, and social scientists will agree on this, there might be a way out of this, and this is reskilling. One of these researchers who are, from my point of view, are using online data in a very skillful way to kind of sketch these pathways, these reskilling pathways, or how jobs are related with regard to the skills that they are combined of, is a paper by Dawson and al. From last year. As I'll be sharing the presentation, all references can be found in the appendix of the presentation, so you need to write this down now if you're interested in the work. And what they did was pretty interesting. They took labor market data from Australia, job advertisements, and they clustered jobs with regard to the underlying tasks that are required. And this very nice map emerges out of it, where you have little dots, and these dots are occupations. And the closer the dots cluster together, the more similar their task profile is. So they kind of map occupations on the landscape of tasks. So the closer they're together, the closer the task similarity, or the higher the task similarity required. And they added another component, which is the color, and that describes the automation risk that I showed you earlier from the Frey and Osborne paper. So you see some of these little islands, or maybe we want to call them ice floes, to make the example of penguins, they are starting to melt. And so the issue for us is, or the task for us is, to show the penguins that need to move away from a melting ice floe to a new ice floe, to a higher one, a more sustainable one, a new profession, how to do this. And this is, I think, a very an interesting and first step to approach this, because now we at least know how close these ice floes are, where to place them on the map, because it's, as you can imagine, very difficult from a penguin to jump to an ice floe that is kilometers away. We can only make incremental steps, so we can only incrementally change our jobs, our job profiles, jumping from one ice floe to the next. But this brings me to the central research question of this work. So now that we know that occupations can be mapped by tasks, so they are relatively close to each other if they have the same require the same skill set, we also see that there are occupations adjacent to each other, where one occupation has a relatively low risk of automation, and another one doesn't. And so this brought me to the question: so if the changes only happen incrementally from one profession to the next, so does it maybe depend does the value of learning a new skill that brings us to a new occupation, does this maybe depend, to what extent does it depend on what we already know? So to what extent is the value of learning something new complementary to the skill set that we or that I already have? Let's move to another domain where I think we might find an answer on this, because in light of unfortunately relatively slow educational or policy response to this, because traditional occupation was, from my point of view, in the last years, not very agile in responding to this, urge for or need for reskilling. If you think about it, on online platforms that I'll be talking about, there were more job advertisements for data scientists than there were actually places to study data science, for example, at universities. In light of this lack of reskilling opportunities, workers, a specific kind of workers, I think, have taken matters into their own hands, and these are freelancers, online freelancers. So, for example, here we see a figure from research conducted by colleagues of ours, where they did surveys with crowd workers, with online freelancers, so people that sell work on online freelance platforms like Upwork, for example, and asked them about how they approach this big challenge of reskilling. And the picture that emerges out of this is that reskilling is, for them, that they rather reskill in a relatively, for traditional economists, in a relatively unconventional and incremental way. So they acquire new skills incrementally, add new packages to their programming languages, maybe that they already know, and they do this on online learning platforms, or they do this in little videos, or on code sharing platforms like GitHub, or maybe on exchange fora like Stack Overflow. So that was the starting point where I thought maybe we'll find some insights on this question, how complementary learning a new skill is to your existing skill bundle on online freelance platform. And luckily, at the OII, at the iLabor group, that is led by Professor Willy Ledonwood, and I'm also happy to see Otto, who's working with us on the iLabor group, in the audience as well. Luckily, there has been, in particular, thanks to these two wonderful people, already a huge body on evidence and on data on what is happening on online labor markets. So, for example, the centerpiece here on the right of the iLabor project, the Online Labor Index, that measures the utilization of this kind of online work across occupations and geography. So there's a relatively rich pool of knowledge and of data to tap into when addressing this question of complementary reskilling. So, but why are these platforms so specifically interesting? Let me try to illustrate this with some theory that I thought to come up with. And that is related to one of the, I think, oldest tricks on the internet. And I would like to invite you to just travel with me a little bit further back in time and think of a time before the internet. Before the internet, if you were a music lover and you wanted to get your favorite song from a band, let's say Deep Purple, for example, you often found yourself in the tricky situation that if you wanted to have this single song that you fancied so much that you needed to actually buy the whole bundle to get the single item. So you needed to buy the album in order to get the single song on a CD, or traveling slightly further back in time, even on an LP, for example. This, though, changed as the internet emerged and as platforms emerged, like Napster, for example, where you could, maybe sometimes through slightly dubious channels, but you could download this individual item. So the individual item was detached, it was debundled from the original bundle that it belonged to. And then moving further on to our times, platforms like Spotify, but not only Spotify, I mean, you could think of providers like Netflix as well, for example, they reversed the trick. So they took individual items from formerly different bundles and placed them together to one bundle, and for $9.90 you can listen to the single songs of your favorite bands in your personalized album, if you want to put it like that. And I think something similar might be happening on these online freelance platforms like Upwork, because before these platforms existed, if you would have needed somebody to, let's say, get data for you from some data source and then perform statistical regression analysis on this, and then find a nice visualization for that, you actually would have needed three individual people with this kind of skill set. So you had to buy the whole bundle, the whole professional bundle, in order just to have this single item. And I think on Upwork right now, these platforms have given rise to the emergence of new occupations where you have a rebundling of these individual skills. As you could imagine, you could hire, for example, somebody that would call herself a data scientist for a specific price, and you have the individual items that were formerly detached from each other in separate bundles now in one individualized bundle. And I think this structure makes it very interesting for us to observe the adjacency of skills and how skills can be recombined and how this recombining might actually be profitable. And so this brings us to the method part of this work and how this is done. What I did in order to unravel this big question of skill complementarity is I looked at data from a set of roughly 15,000 freelancers from Upwork, which is the arguably one of the most popular freelancing platforms globally. And here in the A part of the figure, you see a typical profile like that. So the freelancer, Tatiana, she's a machine learning and natural language processing engineer. And her profile actually tells us quite a lot about the economics and of her profile, of her work. So she has an asking wage. She shows how much she has earned in the past, which country she's from. But for this example, most interestingly, she also depicts in a very granular way the skills that she has. So she not only says that she's knowledgeable in Python, but she's also knowledgeable in applying Python with, for example, packages like scikit-learn, which is used for machine learning, and she does natural language processing, and even does some deep learning, so developing neural networks that are used for image recognition, for example. So a very granular picture on her skills, which is great because we need this granularity to perform the analysis that will now follow. From that, I constructed a network where I linked skills and freelancers. So whenever a freelancer advertised two skills, they were connected to this freelancer, and if another second freelancer advertised one of these skills as well, then they were connected again, to then in C exclude the freelancers from this network and just connect the skills individually. So the more closely connected the skills are, this means that they have been often jointly advertised by the same freelancer. So let's have a look how this looks in practice. In practice, oh yeah, that brings me actually to the first question that we can already address with that. One of the first hypotheses in this working paper is that that it is assumed when you look at the skill literature that similar skills will group together, so that people would naturally often, if they know one programming languages, they would learn another programming language because on the cost side of learning skills, this is relatively easy. It's kind of think of languages as human languages. It is easier for me to learn, for those of you who speak one of these languages, to learn Italian if you already speak French as a German, for example, because you kind of already made the link, and then if adding a similar skill, adding a similar language might actually be relatively easy. The costs are low, and therefore similar skills should group together. Is that really the case? This is the big cluster of skills from this analysis. Almost 3,500 skills from almost 15,000 freelancers. And again, every node is a skill, and they are connected if they have been jointly advertised by the same person. And what I did then is I tried some clustering. I mean, you can experiment, for those of you who've done clustering, network clustering, you can experiment with a lot of parameters. The picture changes slightly, and I'm happy to discuss that, but in a nutshell, there is a structure that emerges from this network, which is represented in the colors, that is pretty persistent. So that emerges no matter what kind of, or relatively irrelevant of what kind of clustering mechanisms or clustering parameters you apply. And so the clustering parameter, or the clustering metric here, tries to reduce the edges. So it tries to avoid that two lines connecting two dots cross all too often. And what emerges from this is a cluster, 8 clusters, essentially, colored here by me in different colors in the end. And the interesting thing about this, to address this first hypothesis, is that if you look at the skills that are highlighted here, and these are the most popular, so the most frequently mentioned skills in each of these 8 clusters, if you look at them, if you read them, you realize that they are also conceptually close. They have conceptual commonality. So, for example, in the top middle cluster, you have skills like Python, JavaScript, PHP, HTML5. These are all programming languages, for example. So this is a cluster that looks at programming languages. Or in the bottom middle cluster, for example, here you read things like writing, proofreading, transcription, translation, content writing. It's all about writing and translation. So interestingly, there is a conceptual commonality, and that already addresses the first hypothesis. It seems to be the case that in general, similar skills like similar skills. They group together. They're often jointly acquired. But what is even more interesting, they not only cluster in terms of contextual commonality, they also seem to be clustering in terms of profitability. So because what I did then is I looked at these skills and I tried to place freelancers again in the network. So a freelancer that predominantly had skills like Python or SQL or JavaScript was placed in the cluster that I called software and tech, for example, or a freelancer that had predominantly skills from this little red cluster in the bottom right corner. So predominantly was commanding skills like corporate law, legal skills, property law, was placed in the legal cluster. And if you look at the asking wage distribution of these freelancers, you see pretty strong differences. And bear in mind that this is a logarithmic scale. So every tick is a tenfold increase. We're moving from $10 per hour to 100 to 1,000 along these lines, with resulting wages, let's say, for example, in admin support of roughly around $10 and all the way up to legal of roughly, I think, $90 an hour. So very, very interesting, strong differences. And you can see at the distributions, these are all pretty much log normal distributions. They're all pretty much like look normally distributed on a logarithmic scale. Another question that I think we are able to address with this data is something about diversity. So there's been a very interesting paper by Anderson published in PNAS, where she argues that diverse skills or diverse skill sets might be more valuable. And I thought it might be interesting to look at this as well. What we see here are the results of a regression analysis. So essentially, I introduced a couple of features to this data set of skills and freelancers. So first of all, I gave every freelancer kind of her specific domain based on the relative majority of the skills that she had, and then also looked at diversity. So whether she had skills from more than just one domain, maybe 2, maybe 3, maybe 4, or maybe even 5 and more. So the highest category, five and more domains, is shown here. These are beta coefficients from this regression and 99% confidence intervals around them. For example, people that are active in 5 and more domains seem to be actually able to add a premium, a wage premium, an asking wage on the median wage of the whole sample. And maybe not surprisingly, you also see things like the coefficient on the very left-hand side. You see that on average, in comparison to the average worker, and keeping everything else constant, of course, in best practice of regression analysis, you see that people working in data engineering, so doing things like machine learning, natural language processing, like we saw with Tatiana in the beginning, they have a very high premium. They are able to increase their the relative increase of their asking wage in comparison to the median asking wage is relatively high. But we also see on the very right-hand side that, for example, past earnings that are also available for each freelancers, they also play a role. So people that have earned, in addition to all these other factors that are shown here, people that have earned a lot in the past are also have a significantly higher average asking wage, controlling for these characteristics here. We can also look at this from a different angle, but it shows a similar picture for 6 the 6 largest of these groups that you saw in the clusters earlier. What I show here are 4 distributions for each of these groups, these domains, these worker domains. And the way you have to read this is the bottom distribution, the one with the 0 on the left-hand side. This is the distribution of asking wages from freelancers that have no additional skill from another domain. So let's say the bottom middle chart, this lowest distribution only looks at freelancers that have only skills that were attributed to the software and tech cluster. But now you move 1 distribution up. That means that there are freelancers that still predominantly were in this domain. So the majority of their skills comes from this domain, but they have a skill from a different domain. For example, there are also the people in the bottom middle chart in the second distribution. They predominantly have software and tech skills, know a lot about programming languages, but maybe they also know how to do creative writing. So they add 1 skill from a different domain, and so on and so on. And you go up until the data, I have to admit, this gets relatively thin because you don't have that crazy diversity looking only at these subgroups. But I think what you see is that for most of the professions, the distribution shifts. And again, this is still a logarithmic scale. So small shifts, small increases are relatively large increases in asking wage in reality. So you see that for many of these professions, the wage distribution shifts to the right to higher wages, the more diverse the skill portfolio becomes on average of the people in these domains. And now let me come to the last working hypothesis of this working paper, which goes back to the initial question. So to what extent is the value of a skill actually complementary? So to what extent does the added value, the potential benefit of learning a new skill actually depend on what you already know, what you already have in your basket? What I did as a simplified example, just to add more contextual grip, is I looked at programming languages. Arguably, these are supposed to represent the most popular programming languages. I'm happy to discuss it, but certain candidates are definitely among them. So you have programming languages like C++ or SQL or Python, for example. And what we see here are, again, the beta coefficients of a regression that controls for the characteristics that I showed you earlier, in addition to a country dummies as well, because we for obvious reasons, economic reasons, we should be controlling for different price levels that exist around the globe. But what we see is that of these popular programming languages, we see that 3 of them seem to, in addition to these individual characteristics, seem to still add something relative to the average or the median wage of the worker. C++, JavaScript, and Python, for example. Interestingly, for the majority of these skills, the results are not really statistically significant. And most interestingly, I was wondering, in the end, I realized that that a programming language like Java, for example, shows a weird negative coefficient. And I've been wondering, like, what does this negative coefficient mean? My interpretation was that on average, looking at the overall sample of freelancers, that people that have this additional skill, keeping everything else constant, statistically speaking, lose with regard to the median worker wage, median asking wage. And that was somewhat puzzling to me, but I think it might be something that can be resolved with the subsequent step of the analysis. Because if it's really true that if it was true that the value of learning a new skill depends on what you already know, you should take this into consideration. So you should kind of truncate the sample and look at different subgroups. And that's what I did here. I looked at these 2 cases again, so a very profitable and on average not profitable programming skill, so Java and Python, but in 2 different scenarios. And these scenarios are selected not arbitrarily. They've been selected because I thought that it's a useful comparison. So again, we're looking at the kind of marginal return, or the return on skill, if you want to call it like this, of these two skills that are, for those of you who know the programming languages, are not that different. It's not a huge difference between Java and Python. You know, it's not like Python and let's say SQL, for example, or HTML5. They're relatively close, but still what we see is that their value matters on, it depends on the context. So if we only look at the subsample of 3D designers, people that are predominantly working in 3D design, we see that Java on average has a higher return on skill, a higher added value on the median wage of 3D designers than Python, while it is the other way around in data engineering. And for those of you who've been working with these languages, that shouldn't be surprising. It's a reassuring finding, actually, because even though they are relatively similar in terms of the structure, in application they are different. So Python is the programming language for data engineering. People that want to do natural language processing and data mining, web scraping, they use Python, they don't use Java, while it is the other way around, you could argue, in 3D design. One more little example, and I think there can be many examples be made once you leave this relatively limiting realm of programming languages. One other example is, for example, looking at Python and Matlab, two languages that are not that similar, but they are both often used in the field of, I think, data engineering. That's a field where they're most commonly probably used together or could be exchangeable. And the interesting thing is, throughout all occupations, you see that Python on average has a positive return on skills, superior to Matlab. So it kind of fulfills this promise of being the big new programming language, or almost an established programming language by now. While for data engineering, the picture flips around. So it seems to be the case, if you look at only the subsample of data engineers, it might be even more profitable on this freelance market to have Matlab instead of Python in your freelancer, in your skill profile. So what you could do from this, and this is just a prototype, but where this might be heading in terms of policy relevance and closing the link again to this grand challenge that I tried to sketch at the beginning, is I think this platform data gives us the unique opportunity to mimic this cost-benefit function, this individual cost-benefit function that is complementary to what a worker already knows or a learner already knows, and gives us the opportunity to sketch reskilling pathways that are more sustainable and more individual. So what you could imagine in a future prototype that leverages data in a nice way is you type in the skill that you already know. So let's say, for example, I know one long programming languages, which is JavaScript, and then it performs the analysis that I just showed you, the regression, and it looks at programming languages or other adjacent skills that are very nice and complementary to what you already know, and also tells you how profitable they might be now, and ideally with time series data, also how profitably they could be potentially, hopefully, in the future. So the takeaway message, oh sorry, maybe one word of cautiousness before I conclude what this study doesn't show yet, hopefully. I try to make a confident impression when talking about you know, how the causality in this whole thing works, even though I have to say what we're looking at here is cross-sectional and observational data. So there are actually, I'm not supposed to make any strong causal claims here, because we do not observe a causal chain or in a chain of event that would allow us to conclude on causality. It would be much better to look at longitudinal data, to follow a freelancer over time, observe once she learns a new skill, and then observe how her earnings and her work history on the platform changes. Even more ideally, you should think of this, it would work in an experimental setting, even though that might be a question to the audience. It's hard for me to imagine to place this in an experimental setting where you allow a certain group of freelancers to earn, to gain, or help them to gain arguably very profitable skills while another one is left alone. But that's maybe a decision for the ethics commission then to improve the research. Second limitation is still theory. I'm trying to look at the benefits that these skills might have for a freelancer, but it should be equally interesting to look at the costs. So how to approximate the costs. I've been thinking about doing this by looking at the distance in the skill network, but that is maybe not the optimal way to go to establish kind of the cost parameter in this function, is individual reskilling function. Then validity, of course. One platform does not necessarily represent the whole online labor market, and it most certainly does not perfectly represent the labor market in general. So this is something that would need to be shown and tested in the future. And then lastly, generalizability. I think I talked about this briefly. We're talking about skills, digital skills. Actually, we're talking only about programming languages so far. Big disappointment. We should widen the scope here, talk about digital skills in general, more generally, and then maybe move on as well, or find ways to move on and talk about skills in general. So not only digital skills. But what we can take away from this already, I think, and there I conclude, is that the insights might be helpful for this kind of transitionary reskilling, moving incrementally from one occupation, from one little ice flow where we are as like freezing penguins and it's sinking and starting to sink, to jump to the next one, the adjacent one, which is hopefully much more stable and much more solid. And the findings that we can take away from this already, I think, are that similar skills definitely group together. They birds of the same feather, they flock together, they stick together. It is profitable probably to have a diverse skill bundle, as we see, and it is most certain that the value of learning a new skill depends on what you already know. Feel free to check out more findings on Twitter or to use the code to have a look at the working paper. And I'm very thankful and happy for all the comments and your attention. Thanks a lot.